Good afternoon, ladies and gentlemen, and a very warm welcome to our webinar, Grassland Fertilisation, Simple Steps to Success. My name is Eva Ross, Marketing and PR Manager for Yara UK and Ireland, and I'm delighted to be joined by my three colleagues, Jon Telfer, Yara's Analytical Services Development Manager, Philip Cosgrave, Country Grassland Agronomist, and Nigel Hester, Area Manager specialising in grassland. So today we're going to cover a number of areas. Jon is going to take us through why testing soil, tissue and manure is important, the role of pH, P and K deficiencies. Philip is going to take us through nutrient offtakes from silage and grazing, what makes up a nutrient plan, and then we'll hand over to Nigel then to go through why is an even spread important, why is it important to select a high quality fertiliser, and why is it important to calibrate your spreader. So Jon, I'd like to hand over to you now to take up your slide there for today.
Okay, thank you, Eva. Hello, everyone. Before we look at soil testing in any detail, just a quick reminder that we did get quite a significant change in the rules in England back in 2018 when the revised water framework came into force. Now, of course, that legislation is there to protect our waterways from diffuse pollution from agriculture, and in particular nitrates and phosphates, by ensuring fertilisers are applied and used as efficiently and accurately as possible. And that, of course, makes good environmental sense, but it does make good financial sense as well. So it's in our interest to take heed of them. So the rules state that any land receiving organic or bagged fertiliser must have a nutrient plan, and they must have up-to-date soil samples in place. And in this case, up-to-date means no older than 5 years at the time of application. So thinking forward, I would say the best way to stay compliant is to soil test at least 20% of the farm every year. And for anyone watching from north of the border, just a quick reminder there that your Committee for Climate Change, who advised your Scottish Parliament, have basically come up with the same advice of introduction of compulsory soil testing. So I suggest it's best practice no matter where you are, 20% of the farm every year. But soil health testing doesn't just mean laboratory measurements alone. We should also be looking to make regular field assessments while we're out collecting that sample, checking soil structure, removing any compaction, ensuring drainage is working as it should, but also looking for signs of soil biology, for the life in the soil, maybe monitoring earthworm numbers, for example. But I would say whether you're going for an in-depth all-out soil analysis, as we can see here, or you just stick into a standard pH, PK, magnesium test, the basics still apply. And any discussion on soil health can and should start, in my opinion, with one simple question, and that is very much, how are my pH levels holding up? Because soil pH affects the availability of all nutrients required for plant growth. And in particular, it does have significant impact on our three main drivers of grass yield: nitrogen, phosphorus, and potassium, or as we usually refer to them, NP and K. Because as soil pH drops, so too do the populations and the activity of the microbes that are responsible for mineralization. That almost magical process by which unavailable nutrients, in particular organic nitrogen, are unlocked from soil organic matter and then converted into the plant available forms, in this case here, ammonium and nitrate. And likewise, phosphorus, which provides grass with its energy source, can be locked up in acidic soils by reacting with undesirable cations like iron and aluminium, and in alkaline soils with soluble calcium. And potassium, required by the grass in huge quantity during periods of rapid growth, such as now, will be less available in low pH soils that are short of more dominant cations that keep that cation exchange system in motion. So for these reasons, we really want to be maintaining soil pH in this relatively neutral zone. So, bearing this in mind, how are we doing? What are the pH levels like in the real world? Well, I've had a look at the 53,000 soils from UK grassland that we tested at our laboratory in Pocklington during the last full soil sampling season. So that's June 2018 through to May 2019. And when looking at that data, we can see, I would say disappointingly, that just over half the samples failed to achieve that RB209 target of 6. And I would say even more concerning, actually over 2/3, almost 3/4 in fact, were below target pH of 6.3 that I would consider to be the optimum for NPK efficiency. So if we're going to get more out of our fertilizers, we need to get on top of our soil pH. And as our title of our webinar is Simple Steps to Fertilizer Success, I would suggest straight away there's step number one. Get on top of pH, maximize the value of the nutrients you already have in your soil, but also to get value out of those we are applying in our muck and in our fertilizers. But does it matter if we aren't making full use of applied nutrients and what we've already got? Well, yes, it does. There's a direct relationship between supply of nutrients and the rate of grass growth that we can expect. And we can see that here. If we look at the left-hand side of this chart, we'll observe that where soil phosphorus levels drop, then so too does our grass yield. And that's why we should take careful note of the P and K index that our soil test results fall into. And now we've popped those on the chart, we can see it a little more clearly. And any result falling into index 0 or 1 is a clear sign of deficiency. And left uncorrected, this will impact on our yield of grass. Index 2 and 3, the green zone, happy days. We want to maintain our soils here, but we should also take note of the right-hand side of the chart, the blue and purple end. And here a result could be considered excessive. And here there's absolutely no benefit agronomically from further applications to these soils. But we also might be increasing the risk to the environment through the runoff of phosphorus into waterways. So our aim here is to reduce those levels over time and get those soils back into the green zone. Makes environmental and financial sense. But just going back again to the risks of deficiency, just to demonstrate this is something we regularly showcase at our nutrient research glasshouse at the laboratory in Pocklington. So both these pots we can see now were sown with the same amount of grass seed on the same day. They both have the same light, the same water, but they've also both been given exactly the same amount of nitrogen. But the pot on the left, we've let that go short of phosphorus. So we've pushed it into index 0 or 1, if you like. And you can see the effect on dry matter yield as that grass has failed to establish. So identifying and correcting a low P index is critical. Yet, over 1/3 of the grassland soils we see through the lab are classified as deficient. And I would say equally concerning from an environmental perspective is the 1 in 10 soils that demonstrate excessive levels. So please keep an eye on these P and K indices. And just to show that potash works in the same manner, we can see that effect again with another pot trial. Again, both pots received full nitrogen program, but the pot on the left, we've allowed to go short. And we've lost about 1/3 of our dry matter yield there. Yet, around about 40% of the grassland soils we test fall into this very scenario. So that is grass, potential grass growth that we're simply losing, all for the want of a bit of potash. And if left untreated, this loss of yield will increase year on year, as we can see with that data from the PDA there. So I would say that's my second simple step to fertilizer success: identify and address phosphate and potash deficiencies. But grass, as we know, doesn't just require NP and K. There are many secondary and micronutrients that play their part in its development. And the deficiency of just one of those will be enough to limit growth and yield and quality. So think beyond the basics when you come to your testing. But if we're focusing on fertilization success, then I think we should spare a few minutes to consider sulfur, an essential nutrient that works in synergy with nitrogen, building both quality and yield. I'm sure you're all aware, and you've seen that chart on the left many times, I'm sure, of just how successful the Clean Air Act has been in reducing emissions from industry and from power generation and so on. But one of those consequences of that, if you like, is you know, it's a success. But as far as we're concerned, we've seen a drop in the deposition of atmospheric sulfur. Conversely, on the right, we've got a chart that shows the rate of sulfur deficiency in UK soils over a similar time period. Back in '95, which is as far back as our database stretches, around about 60% of soils had an inadequate supply of plant available sulfur. We fast forward to recent years and it's around about 90%. Now, over that time and those million plus soil samples, we haven't changed the method, we haven't moved the guideline of the target level. So all that can have happened is that soil supplies of plant available sulfur have really become all but exhausted. And I suppose this is why so many grassland grades now have a sulfur component to them. Grass has an essential sulfur requirement that may not be satisfied by the soil alone. So how might we know if we need sulfur? Well, we can test the grass itself. And here, as there's a close synergy between sulfur and nitrogen, it's the ratio of the two which really we should be looking at. And for optimum yield and quality, grass requires 1 part of sulfur for every 12 parts of nitrogen. So we set our target ratio at 12:1. Hit that, and we get our sulfur management right. So this chart here is showing you the long-term distribution of the many thousands of grass samples we've analysed in our laboratory. And I can tell you that around 2/3 of these samples have a nitrogen-sulfur ratio higher than 12:1. So we're getting it right about 1/3 of the time, but 2/3 of the time, I'd say there's an opportunity to look again at sulfur management and improve both yield and quality. And as I said before, this will impact on our nitrogen use. So going back to our pots from our little trials, both pots, same nitrogen application, but look at the difference where we're letting that sulfur go short. We're losing about 1/4 of our yield. And this degree of yield loss has been replicated time and time again at field level. So if we're using nitrogen, remember to consider the sulfur. And I'd say there's simple step number 3. Test your grass for mineral content and pay particular attention to this nice nitrogen-sulfur ratio. And finally, in my brief run-through analysis tools, I'd just like us to think about the contribution from a key on-farm assets, and that's slurries and manures. And without a doubt, they can contribute significant amounts of nutrition, and they should always be our first consideration when putting together any nutrient management plan, with bagged fertiliser then topping up any further requirements. But slurries and manures are, of course, unpredictable materials, and their contribution will change depending upon rationing, the weather, even how we apply them, and so on. But just to give you a flavour, if you'll excuse that expression when talking about slurry, of this variability, we can look at some real-world data generated from the samples we test at Pocklington. Although I have to say at this point that when it comes to the analytical team, they're not the most popular samples to arrive through the door. Anyway, on we go. So according to RB209, a typical 6% dry matter slurry will contain around 2.6 kilograms per cubic meter of nitrogen or per ton. So if we want to think of that in terms of what we apply, that's about 6 units of available nitrogen per 1,000 gallons of slurry, if we're putting it on by splash plate. And on average, that typical value is about right when we look at the average of all the dairy slurry samples that we analysed through our lab last year. But when we look at the bottom quarter of samples, if we like the least concentrated samples, we find there the average nitrogen content is around about 0.9, less than 1 kilogram of nitrogen per cubic meter. And that means in the real world, if we like, 1,000 gallons of slurry there are actually only delivering 3 units of available nitrogen. Conversely, if we look at the richest quarter, we see that nitrogen content has shot up to nearly 6 kilograms per cube. And again, in real world terms, that means we're delivering now 10 units of available N. And we see this same level of variability in phosphate, potash, and sulfur content as well. So slurries, manures are movable feasts, but they are rich, valuable assets that we should make the most of. So I would say this is my simple step number 4. Test your slurries and your manures. And knowing that nutrient content precisely will help you use them more efficiently, help you put them where they are needed, resulted in far better predictability of grass growth rates, and perhaps even reducing your bagged fertiliser requirement. So to summarise, soil testing really is a must, not just to satisfy regulatory requirements, but also to maximise your nutrient inputs, and as part of an initiative to monitor and improve soil health. Remember, 20% of the farm each and every year. Managing pH and keeping on top of your lime management is as important as ever, yet 70% of the samples we see don't hit the mark. Identifying correct low P and K fields, these are the fields where we should be targeting our slurry manure use. Put it where you'll see the benefits, not just where it's convenient. And if we are testing, remember there's more to life than NPK. Soils can be tested for a whole host of parameters. So if you've collected that bag of soil, make the most of the opportunity. Don't forget you can test the grass, particularly look at that nitrogen-sulfur ratio, and remember that target of 12:1. Also manures, slurries, any other waste brought into farm, again, if you measure these, you can manage them far more effectively. And finally, please use test results. Use those soil analysis results. Don't just stick them in a drawer, and compare them from year to year. Are your soil fertility levels rising, or are they in decline? And finally, a personal plea, please do use a fully qualified advisor, a FACTS qualified advisor, to help you select the best fertiliser products for you, and how to assist you in planning how best to apply them. So I'd just like to say thank you for your time. Now I'd like to hand over to Philip, who is going to tell us more on the very subject of how to approach a nutrient plan and how to get the very best out of your choice of fertiliser. Thank you very much. Philip.
Thanks, John. And I think what John has just discussed there connects very well with what I'm going to talk about here, the kind of implementing, you know, the analysis that you do on whether it's soils or whether it's on your manures. And basically my point here will be, you know, nutrient planning and understanding nutrient offtakes on grassland farms. So, you know, the question might be asked, why do we need nutrient planning? Well, as John pointed out there, they're now necessary since April 2018. They're a regulatory requirement. And secondly, they can make your farm more efficient and also more sustainable. Like putting a nutrient plan in place in your farm shouldn't be seen as a task that you won't see a return from. It's really an accounting exercise where you're balancing the nutrient requirements of your grass in this case. So, you know, inputs and offtakes. And to start, you'll need section 2 and 3 of the fertiliser manual, or RB209, as John has also mentioned there. And you can if you don't have these, you can download this from the HDB website, or you can call them and have them post them out. So, you know, this takes us on to what makes up a nutrient plan. Well, firstly, what are the nitrogen, phosphorus, potassium, and sulphur requirements of your grass crop, whether it's for silage or grazing? This can be found in section 3 of RB209. And we should also have a soil test result at hand for this part, as we need to know the soil P and K fertility status of each field or paddock. Once we've established what the crop needs are, you know, can a part or all of those requirements of the crop be met by using this, you know, this rich, you know, resource that we have in our farm, these manures? And for this, we need to put a nutrient value on them. Now, using either, you know, standard book values contained in section 2 of RB209 or the results from analysis, as John has discussed. But before we know and can actually put a value, a total and plant available nutrient value on these manures that we have available to apply. So finally, you know, the shortfall in nutrients from manures is calculated so that, you know, you're choosing the right mineral fertilizer can be actually sourced and applied. This might mean a compound NPKS grade, or it just might mean a nitrogen and sulphur product, or maybe none at all. So this is where I'm going to now go into more detail on just some of the offtakes on different grassland systems, which I think is important to know and to understand. So these are, I suppose, grazing offtakes. And if we take it that 1 ton of grass dry matter that a cow eats, there's 6.9 kgs of phosphate in that ton of dry matter. There's 33 kgs of potassium in that ton of dry matter. And I might add that all my P and K figures here are in P2O5 and K2O, so they're not elemental P and K. So as we said, if the cow eats a ton of grass dry matter, that's how much P and K she's eating. So what's actually happening is that some of those nutrients are being retained in whether it's in live weight gain or in milk. So basically, we're approximating that about 40% of that phosphorus in that ton of dry matter is actually being retained by the animal, and 10% of the potassium. Now, we'll say that that's more for dairying systems, that you've got that 40% of phosphate. Maybe in, you know, when it comes to beef farms and sheep farms, it's probably less than that. It's probably closer to 20% of the phosphate is retained by the animal, and more like 5% of the potassium is retained by animal. So there's an event on a dairying scenario here. 60% of the phosphate is being excreted, and 90% of that potash is being excreted. So what we have is we've a removal of about 2.8 kgs of phosphate and 3.3 kgs of potassium from the field in every ton of grass dry matter consumed. For silage offtakes, well, we've the same amount. We're saying here that there's the same amount of P and K in that ton of dry matter. But because we're harvesting it, we're removing it all. There's none of it being excreted on the field. So you're removing 100% of that P and K. So you're removing all that 6.9 of kilos of P and 33 kgs of K. So that's important to bear in mind. If we kind of extrapolate that up to a typical, well, maybe not a typical silage system, but if we're on a 3-cut system, and maybe we can disagree over my yields for those individual cuts, but if you have a 3-cut system or 2-cut system, you can see there the actual offtakes of P and K. So they're quite considerable offtakes of P and K in a 3-cut system there at 70 kgs of phosphate and 330 kgs of potash. So this basically means this is going to influence our I suppose the requirements of our crops, the crop requirements for P and K, and how we do up a nutrient plan. So basically, cutting removes 2.5 times more P and 10 times more K than grazing. So this brings us now to the actual I suppose those requirements. So this is a table taken out of RB 209. You can see here this is for the grazing recommendations, and I've highlighted there. We're trying to achieve the optimum soil P index is 2, and the optimum soil K index is 2 or 2 minus. So we can see there at that optimum soil P and K index of 2, there's 20 kgs of phosphate required and 0 kgs of potash required on a grazing system. Now I will say, I just have some notes that I've written down here, in that, for maintenance requirements. So if you were at that index 2, it said that you only need to apply maintenance. So you just need to keep topping up what the animals are removing by way of milk and live weight gain. So, and I think that 20 kgs, if you remove, it's very much down to, the offtakes and how much grass you're growing. If you're growing 12 ton or maybe 15 ton of grass dry matter annually on a paddock or on a field, and you're utilizing, say, 12 ton of that, so the actual animal is eating 12 ton of that 15 ton, pretty much the offtakes go into milk and live weight is more like 34 kgs per hectare. So you need to assess your system. If it's a very intensive system, if you're growing a lot of grass, producing a lot of milk off grass, well, then it's likely that you need to up your maintenance application of phosphate, and that's allowed in the RB 209. So if you know what your offtakes are, then you can address that by applying more phosphate then to keep and maintain that optimum soil index of 2. And we also should account for that if livestock are being fed cake or concentrate while they're grazing, each ton of that concentrate that's being fed contains about 10 kgs of phosphate per ton. So we can allow for that then, because then that basically the excretia has been enriched with more phosphate. Then we can multiply that up by our stocking rate and our stocking area, and we can actually then possibly reduce the amount of phosphate we need to top up by way of applications of slurry or mineral fertilizer, mineral P. And for that matter, K, there's no requirement for K, but in intensive systems, again, if you think that 1,000 litres of milk removes 1.3 kgs of potassium, and if you have a 2.5 cows per hectare stocking rate, and each one producing, say, 13,000 litres of milk per hectare, that's an offtake of about 17 kgs per hectare. So for those intensive systems, I think it would be worthwhile actually, making sure that around about 20 kgs of potash is applied to maintain that index 2. And also on intensive grazing systems, if you take a paddock out for management purposes, if you take a paddock out from a rotation and cut it for silage, well, then you also need to take that into account. That's going to actually deplete that paddock of potassium or of potash. So it's important then in that instance there that you may be worthwhile going in with an application of slurry to replace particularly that potash that you've taken off, to keep that maintenance requirement up, or up at that optimum too. So this is where our products, with that like a Yara, one of our products, the Yara products 25-55. That's why, you know, we're using that, you know, the ratio of 1:1 there for P and K, because it's been showed, you know, for the last, with research done back in the 60s and 70s, that using those products is effective at maintaining or replacing the offtakes from livestock systems. If we look at a second cut silage, and I'm just taking this point, you know, we should nearly look at silage systems in their entirety over all of the different cuts, but for the sake of this seminar, you know, we're looking at second cuts. So we can see there that's a table taken out of section 3 of RB 209 for the P and K requirements. So we can see, we're hoping there that you can see for phosphate it's the same regardless of the index. So you're hoping that in the first cut that the actual build-up rates have been applied for that first cut. So there's no need for the build-up rates to be applied at the second cut. So you're just purely applying the maintenance rate. But similarly for potash, you are looking to apply build-up rates, because those build-up rates, you haven't applied all of the potash removed in that first cut, because you don't want to over-apply potash in that first cut, because you don't want luxury uptake of potash. So it's a good time for the second cut then to actually to replenish soil K, and there's no you haven't got the same problems with luxury uptake of K for in second cut growth. So our nitrogen requirement, taking that from RB 209, is between 90 and 100 kgs of available nitrogen per hectare, and a sulphur requirement of 30 to 40 kgs of SO3 per hectare. And I must say that's not just for second cuts, that's for each cut. So if we're looking now at the nitrogen side of it, or for the organic manure side of it, regardless of how you apply your organic manures, it doesn't affect the P and K availability, but the actual nitrogen aspect it does. So for the available nitrogen, the way you spread your slurry has a big impact on that. So as we see in that graph there, as you move from splash plate to dribble bar, trailing shoe to injection, you're actually improving the amount of nitrogen you're capturing in your manure there, and you're minimizing ammonia losses as you use those different systems. So I basically, particularly for if you want to get the most out of your organic nitrogen, or that available organic nitrogen, you know, look at using some of these techniques and come off the use of splash plate and possibly go to trailing shoe and injection to maximize the value of your of that slurry that you have available. So what's in cattle slurry? So we can take, you know, either our, you know, this is the book value from section 2 of RB 209. But if you have an analysis from the lab, like land crop, as John discussed, you know, that's when you can really hone in and actually get you know, fine tune that nutrient plan for a silage crop, or in grazing scenarios. So for nitrogen, if you use by splash plate at this time of the year for, say, a second cut, we're saying you're going to get 7 kgs of available nitrogen. But by trailing shoe, you're getting 9 kg. So there's a really worthwhile benefit there, and that's an 11 meters cubed, or the same as 1,000 gallons per acre. For sulphur, we're getting about 3.5 kgs of available sulphur in that 11 meters cubed. For P and K, it's a little bit different in that in the index 0 and 1 for P and K, or for soil index P and K, you actually use only the available fraction to calculate a crop requirement or a nutrient plan, whereas if you've got a soil index at 2 or greater, well then you just use the total P and K in that organic manure. So that's an important point, and it does confuse some. So there's just, I suppose, some figures you could jot down and to balance, you know, if you're looking to fertilize your second cuts in the coming days or weeks. So this is just a simple example of that second cut fertilizer recommendation, where your soil P and K is at index 1. So as I said, from the very first slide, the crop requirement, establish that first. You can see there across the top line, 100 kgs of nitrogen, 25 kgs of phosphate, 90 of potash, and 35 of sulphur. So what's 22 meters of cattle slurry, which is the equivalent of 2,000 gallons per acre, going to contribute? And this is by splash plate. So it's 14 14 kgs of nitrogen, but if you apply that by trailing shoot, that would increase that by 4, so it will be 18, but then it's 14 of P, 50 of K, and 7 of S. So it's basically a deduction then. How much mineral fertilizer do I need? So you need 86, so you just deduct what your slurry is contributing minus the crop requirements to give your fertilizer requirement. And that will vary on farm with the amount of organic manures that are being applied and the type of organic manures that are being applied. So this is where you need to actually use a product and not just use the same product every year. So you've got the chance now to use a product that will actually, so that you're not over applying nutrients or not under supplying nutrients, to actually grow you the best crop, both yield wise and quality wise. And my second example here is where the soil P and K index on a particular field or paddock is at index 2. So the optimum index for P and K. So the same again, same crop requirement, applying the same amount of slurry, 22 meters cubed or 2,000 gallons per acre. So if you can see the fertilizer required here, there's no phosphate required in this scenario. So therefore, you could use a product, a 0P mineral fertilizer, say something like Yara, Mila, NK, Sulphur, which doesn't contain phosphate. And that will then be able to supply the nutrient requirements of that second cut silage. And finally, to summarize, put a formal nutrient plan in place at the beginning of the year. It doesn't have to be, it can be on a spreadsheet, but it can be written out on a piece of paper. But it is important to formalize it, that you have it there, and that you keep it, that if you're asked in a year or 2 years' time, that you can actually show that they've records that you've actually had a nutrient plan. And similarly with make sure that it has to be changed. If you go from taking 3 cuts of silage to 4 cuts of silage, well then you'll have to amend that plan at some time during the year. And then I suppose the main thing is to try and maintain your soils that optimum P and K index, because if you maintain that optimum P and K index, it's going to be, you're going to grow better crops, but there's also going to be an efficiency aspect there on your farm, and hopefully that will relate back to a more profitable, sustainable enterprise. So thank you for that, and I'm now going to pass you on to Nigel.
Okay, good afternoon, everybody, and hope you can all hear me loud and clear from my home office down here in deepest Devon. So yeah, just before I start, just like to give a personal thank you really to all you farmers out there feeding the nation in these difficult times, and certainly think we all probably share a sense of purpose in the wider industry here, whether we're supplying your inputs or advice or marketing or processing your produce. So thanks to everyone really for keeping the show on the road. So yeah, having tested the soil and manure, as previous speakers have been saying, and undertaken a nutrient management plan, we then need to ensure that we accurately and evenly apply the fertilizer program. Well, why you may well ask? Well, certainly nitrogen is the key driver of yield, and the economic and environmental impact of uneven N application can be significant. We find that nitrogen trials will typically double the harvested yield, but we know an oversupply can impact on silage and grazing quality and have a negative environmental impact in terms of greenhouse gas emissions or nitrate leaching. Also, that undersupply clearly can have impacts on yield and quality as well. So getting the right amount on the crop evenly is clearly important. And for P and K, we know P is important for root development, and potassium for water regulation and stem strength. And again, uneven spreading, will have an impact, particularly at lower index fields, perhaps where the requirement is higher. But also, we perceive greater risk from uneven spreading from manure applications. As we've seen earlier, this is powerful stuff, and there certainly is a need to calibrate and maintain those spreaders to make sure they're operating in good order. And clearly, from an environmental point of view, phosphate getting into water it is not the right place for it, leading to eutrophication of water courses. So Yara has a comprehensive range of products that will balance every farm's soil fertility and manure applications. And the booster range shown here is our specialist grassland range, all containing selenium, which will give animal health benefits. They also contain sulphur and are suitable for cutting or grazing. And just to note that the stock booster S product there on the left is marketed in Ireland as Super Booster. So we've cross-referenced all our product range with all the major spreader manufacturers, some of which are, well, most of which are shown here. And we have sent samples to their test tools for them to process and then post the results on their website. We find that not all of them have been tested yet, and there's certainly some still in the pipeline. But if you're missing the product that you have, selecting a product from the same Yara factory will be a good starting point. And to that end, we've now put the Yara product and factory code on all our bags, as shown on this silage booster example at the top of the back of the bag. And we've asked the spreader manufacturers to use these codes, as well as our local product name on their websites, to help you match with the product you've purchased. We do have different Yara factories supplying our market here, and sometimes the same grade and analysis. And this code is a unique product for each product. And the UKI abbreviation there is our factory in Finland, where this particular product comes from. So these spreader manufacturer settings, while they are useful, are only ever a guide, because they're only based on one spreader and one fertilizer sample in a spreader test tool in Europe often, but they obviously do provide convenience to you. And although we provide good consistency from bag to bag and year to year, the only guaranteed method of matching the product you have purchased with your spreader is to do a tray test. And qualified engineers will ensure an even spread pattern at your chosen bag width, and their services are recommended. Spreader and Spread Testing Limited is one such business offering this service, and we asked them about their experience when undertaking tray tests on farm. They said that 70% of spreaders they check need adjustment, and that includes even new ones with factory settings. 50% or so of the final spreader settings differ from the spreader manufacturer website settings, but they often use these as a starting point. And when not available, their engineers assess the product characteristics or use information on their own extensive database. They also find that 25% of the spreaders they test have worn parts that need replacement. And the vanes are the most common wearing part, although some manufacturers are now using hardened coatings, which are extending their working life. And also the agitation systems are common causes of spreading problems, and checking how fertilizer flows onto the disc is an important consideration. So the target coefficient of variation, as shown on the graph in the green zone here, is to be under 10%. But you can see that there are significant financial penalties from inaccurate spreading as we move to the right-hand side. And on nitrogen responsive sites, which is shown with the sort of light blue diagonal line, we can see at coefficient of variation 20%, you can be losing up to £40 a hectare, and at 30% up to £90 a hectare. So these are significant penalties, which will quite quickly outweigh the cost of trade testing and the premium price of a quality fertilizer. So physical size is important, size and strength and other characteristics. So the granular products, as shown on the left, typically are Yara, Bella, Extran and Axan, will have a median size of around 3.5 mil and will be harder and be able to spread further. In fact, we have calibration settings up to over 50 meters. And while prill products can be spread accurately, certainly up to probably 24 to 30, the smaller and the softer the products are, that will become more challenging to get a good setting, certainly at wider back widths. So typical raw materials used in blends are often ammonium nitrate, which is 33.5 to 34.5% N, DAP, diammonium phosphate, which is 46% phosphate, MOP, muriate of potash, which is 60% potash, and ammonium sulfate containing 60% sulfate. Often Often these are not physically compatible and can segregate, and obtaining a good spread pattern will be difficult. The source of these raw materials can also vary, as shown in the images of the typical 2010-10 samples on the left of the picture. And as these raw materials are concentrated sources of nutrient, they are often used at very low percentage of inclusion in the finished blend to meet the final declaration. A 25-55 blend, for example, will only contain 8.3% MOP. So a Yara complex compound fertilizer, or CCF as we call them, will have all the declared nutrients in every prill or granule, whether it is an NPKS product as shown, or an NS or an NKS product. This will increase the number of nutrient landing sites as for all the nutrients it contains. And in this example of a 25-55 fertilizer spread at 300 weight an acre in old money for those of you imperial measures, which is 370 kilos a hectare, it shows the difference in the number of nutrient landing sites measured in particles per square meter and the distance between them measured in centimeters for a blend on the left and a Yara CCF on the right. So for the phosphate part shown as P, we see the number of particles is 144 per square meter for the blend, as shown against the top red arrow, and just over 1,000 for the Yara CCF as shown against the top green arrow. The distance between the P landing sites is 8.3 centimeters for the blend as shown against the bottom red arrow, and only just over 3 centimeters for the Yara CCF shown against the bottom green arrow. And this will go some way to explain yield benefits found in trials using a Yara CCF, as it will give a better supply of nutrient to the crop. So to find an engineer local to you that can provide a trade testing service, please go to the NSTS website shown, where also the contact details for SES can be found. And also our own website there has a number of resources on spreading advice and provides links also to all the major spreader manufacturers' websites, as I showed earlier. So just a summary of the key points is basically to say to select the correct grade of fertilizer and apply it accurately and evenly at the correct rate and timing, to focus on value, not just price, and select the best physical quality fertilizer available. And that our CCFs will provide more consistency and reliability and will not segregate. To calibrate your spreader, either by using the spreader manufacturer data, or better still, to undertake a trade test to give you the best result. And all of this together hopefully will help you get the very best return on your investment in fertilizer while taking care for the environment. So yeah, final thank you just to STS for their contribution, and to hand back and say thank you for listening, and to hand back to Eva. So stay safe, everyone. Thanks very much.
Thanks very much, Nigel. Again, many thanks to the three gentlemen joining me this afternoon, and we'll hopefully catch up again soon with everyone in a webinar in the next few weeks. Thanks, everybody. Take care.